Hello and welcome back to Instant Seekh. मेरा नाम है कृष्ण कहार. In this video we will be continuing with our UGC NET Computer Science PYQ series. आज के इस वीडियो में हम देखेंगे अगस्त 2024 में कंडक्ट हुए कंप्यूटर साइंस पेपर 2 के सॉल्यूशंस. ये री एग्जाम जो आपका ऑनलाइन कंडक्ट हुआ था जून साइकिल का, उस पेपर का ऑनलाइन जो पेपर कंडक्ट हुआ था उसके सॉल्यूशंस हम आज देखने वाले हैं, स्टार्टिंग फ्रॉम क्वेश्चन नंबर 1 टू क्वेश्चन नंबर 50. इसका पार्ट 1 में हम 50 क्वेश्चन सॉल्व करेंगे एंड पार्ट 2 में another 50 questions. Okay, so let's get started. Do join our Telegram channel for the PDF detailed solution PDF or PYQs and other notes as well. Okay, so let's start with our question number 1. Okay, let's start with our very first question. What it is? Question number 1. Let P be, it is a hot day, and Q be, the temperature is 48 degree. Write in simple sentence the meaning of negation of P and negation of Q. Very simple question. Okay, so what is P given here? P is, it is a hot day. Will be the negation of P. Negation of P will be, it is not a hot day. Okay, what is Q given here? Q is, the temperature is 48 degree. What will be the negation of Q? The temperature is not 48 degree. So out of this option we need to identify such statement where it states it is not a hot day and the temperature is not 48 degree. Okay, if you see from all these options, which one is the possible answer? Okay, C1, right? What it states, it is neither a hot day nor temperature is 48 degree, because if you see rest one, it is a hot day, which is not valid because negation of P says what? Negation of P says it should not be a hot day. Okay, temperature is 48 degree, again it is straight away Q, not negation of Q. Okay, it is not a hot day, not a valid statement itself. Okay, so option C is the right answer for this particular question. So answer C is your right answer. Let's move on to the next question. Arrange the following steps of file handling in C in the correct order. Okay, so we need to arrange it in proper order how the file handling takes place. Okay, so first of all, what we do first is we open the file. Okay, then we check for errors. Third is we do our operation that we want to perform, either read or write operation, and at last we close the file. Okay, so your correct pattern will be, that is, first we open the file, that is option number C, then we check for the error, that is option number D, then we do our operation, that is read and write operation, option B, and at last we close the file after our operation is done. Okay, so the correct sequence is C D B A, that is your option number C. Okay, so your correct answer is C. Let's move on to the next one. Okay, out the following step in proper sequence for simplifying a boolean function using a Karnaugh map or K map. Okay, while mapping the K map, okay, for simplified expression, what are the steps involved? Okay, that actually we need to pen down that. Okay, so first step that we do is draw the K map. First what we do is draw the K map for the given boolean function. After that we transfer the values, right? Transfer the truth table values to the K map. After that we do what? We identify and group the cluster. Identify and group the cluster, and at last what we do? We write the simplified boolean expression from the group cluster. Okay, so the correct sequence is option B. First we draw the K map, then D, option D, we transfer the truth table values to K map, then option A, we identify and group the clusters, and at last what we do is we write the simplified boolean expression from the group cluster, that is option number C. Okay, so which option matches this pattern? B, D, C, A. This is matched by your first option itself, that is option A is your right answer for this particular question. Let's move on to the next one. Okay, we have matched list 1 and list 2. Okay, computing systems are given and their working and individual outputs are given. Okay, half adder we know it is used for what? Addition. Okay, so from these options where it is, you can find the addition 2-bit addition circuit here. Okay, so this goes for option A, right? So A goes for 4, then you can eliminate, right? So these two can be eliminated, option A and option D, right? Next, decoder. Decoder, let's say you don't know what decoder is, let's move on to the register. Register, you know, CPU storage unit, right? So C goes for second. Check for the option from these two, which goes C goes for second. Okay, so this gets eliminated. This will be your right answer. Let's see the options. Decoder goes to first, that has n input and 2 raised to n output. Register is your CPU storage unit, and your main memory is used to store program at runtime. Okay, so your correct answer will be option number C, that is your half adder is a 2-bit addition circuit. Decoder is what has n input and 2 raised to n output. Register is CPU storage unit, and main memory is used to store program at runtime. Okay, so answer C is your right answer. Let's move on to the next. Okay, find the correct sequence of the storage devices in the ascending order based on their access time. Okay, slowest to fastest. Okay, remember the metric here. Here they have asked for access time. Based on access time, you need to arrange the sequence starting from the slowest to the fastest. Okay, so the correct sequence we need to identify. You know the fastest is what? Register, right? Okay, so this will come at last. Let me put it as 5. Okay, above that we have a what? Main memory. Okay, next is what? Magnetic disk, that will come 3. Then optical disk. Okay, and then the slowest one is magnetic tapes. Okay, so your magnetic tapes, option C, your magnetic tapes are the slowest. Option E is the optical disc, second slowest. Then we have option B, your magnetic disk. Then option D, your main memory, and the fastest is our registers. Okay, so C, B, D, A, this will be your okay pattern storage device in ascending order with respect to access time starting from slowest to fastest. Okay, which of the option matches this pattern is option number D. So your correct answer for this particular question will be option number D. Okay, let's move on to the next one. Okay, let's see the next question, that is question number 6. What it is stating: consider the following statement regarding special purpose register. PC program counter keeps the track of next instruction executed. Instruction register holds the address of first instruction to be executed. Accumulator holds the output of ALU. Program counter keeps the track of only first instruction of the program. Okay, from the above we need to identify which are the correct answer from the above given options. Okay, which of the following above statements are correct. Okay, so if you see, PC keeps the track of next instruction to be executed. Yes, this is the correct statement. PC act as the next iterator. Okay, from where the next instruction will be fetched, or from where the next instruction is to be executed. Okay, so this statement is correct. Next, instruction register hold the address of first instruction to be executed. Bro, this is wrong. Okay, instruction register holds the address of first instruction to be executed is not correct. Basically, it holds the current instruction being executed. Okay, not the first. Okay, next, accumulator holds the output of ALU. Yes, this is correct statement. Register A, also known as accumulator, holds the temporary output. Okay, during your microprocessor processing. Okay, last, program counter keeps the track of only first instruction of the program. This is not correct. Program counter continuously keep the track of the next address of the next instruction that is to be executed. Okay, not only the first one. Okay, so this is incorrect. So only your option A and option C is correct, which is in your given option, that is option A. So your right answer for this particular question is answer A, that is option number A. Let's move on to the next one. Okay, we have matched the list, with list number 2. So we have first representation of bit, physical address, logical address, segmentation and reassembly, and we have given the layers net. Okay, we have given the layers. So let's see one by one. Okay, you should be able to identify any two of them. Okay, physical address is refers to what? Data link layer. Always physical address refers to what? Data link layer. Okay, so this option goes for what? Option B. Okay, B goes for 4 in which option you can see, and you can eliminate the rest by the time. Okay, here B goes for 4, here B goes for 4, so we can eliminate option A and option C. Okay, okay, now next, logical address. Logical address is basically handled by network layer, is handled by network layer. Segmentation and reassembly, this is done by transport layer. This is done by what? Transport layer. And representation of bits is basically done uh, is basically done by what? Physical layer. Okay, so your correct answer is A goes for what? A goes for 2, right? A goes for 2. Okay, so A goes for 1 year, so D gets eliminated. A goes for 2, that is representation of bit goes for physical layer. B, physical address goes to data link layer. C, logical address goes to network layer, and segmentation and reassembly is handled by your transport layer. So your right answer is option number B. Okay, option B is your right answer. Let's move on to the next one. Okay, which of the following properties correctly describe a regular grammar? Okay, from the given properties, which describe a regular grammar correctly. Okay, so all production rules are of form A to XP and A to X, where A and B are non-terminal symbols and X is a terminal symbol, meaning A and B are variables and this X is a terminal symbol. So this is your correct statement, first of all. Next, regular grammars are more powerful than context-free grammars and can express any type of language. No, this is wrong. Okay, this statement is wrong. Our regular grammars are actually less powerful than context-free grammars. Okay, and regular grammars can only describe regular languages, which are a subset of context-free grammars. Okay, so this is wrong. Option C, there is a direct correspondence between regular grammar and finite automata. Yes, this is right. Okay, and it is also vice versa as well. Okay, so this is right. Next, regular grammars can generate languages that are not recognized by any type of automata. This is incorrect because regular grammars can only generate regular languages, just now we discussed. Okay, which are precisely recognized by the finite automata, not by any type of automata. So this is also wrong. So your only option A and C are right. That is your option number D. So your answer is option D for this particular question. Let's move on to the next. Okay, question number 9. Arrange the steps in proper sequence involved in GA, that is genetic algorithm. Okay, so what are the sequence of step? Okay, follow. So first and foremost step is initialization. B option, that is initialization. Then we do evaluation. Okay, evaluation. Then selection of particular this, and then we do what? Crossover, and at last we do mutation. Okay, so your correct sequence is B. First we do what? Initialization, then E, evaluation, then A, selection, then C, crossover, and then D, mutation. Okay, in genetic algorithm we follow this pattern. Okay, so of the given option, your option number C matches this particular pattern. So your correct answer is answer C. Let's move on to the next. Okay, again match the list is given. Okay, processing type of systems are given and their definitions are there. Okay, so let's see one by one. NLP, natural language processing. Okay, so you should be able to know what NLP is used for. Okay, this is for human language understanding. Okay, so straight away you can see here NLP you can match with this option number 3 here. Okay, so A goes for 3. A goes for 3. Rest you can eliminate. So option A gets eliminated. Option D gets eliminated. Right. Now, next, the easiest one is expert system that you need to able to understand. Okay. So expert system is what? Expert system is basically system designed to emulate, system designed to emulate the decision making abilities of a human expert. Okay. So your D goes here, that is for second. Okay, so let's check if we can eliminate the rest. Okay, D goes for second, so this is our correct option and this gets eliminated. Okay, rest also you can check. A goes for third, we have already marked. B goes for first, reinforcement method of training algorithm by rewarding. Okay, so this goes, B goes here, and the remaining support system vectors, a machine learning technique that finds the hyperplane and separates the and batch separates different class in feature space. Okay, so C goes here. Okay, so your correct pattern is A goes for 3, B goes for first, C goes for 4, and D goes for second. Okay, so this is your correct answer. Okay, answer number C is your correct answer. Right, let's move on to the next one. Next we have is arrange the following stages of Turing machine operation in the correct order as they occur during computation. Okay, again we need to arrange the sequence. Okay, so we have given writing a symbol, moving the tape, reading a symbol, transition to a new state, and halting and accepting a halting and accepting or rejecting the input. Okay, so you should know this is the last. Okay, E1. Okay, let's see one by one what is the correct sequence. First of all, the first very step we do is reading a symbol from the tape. After that, transition to a new state based on the current state and symbol read whatever the symbol we are reading. Okay, then what we do, write a symbol on the tape. Okay, after that, moving the tape head left to right, and at last what we do, halting and accepting or rejecting the input. Okay, so this is the sequence. Okay, so what is the sequence? Once again, C, first we will read a symbol from the tape. Okay, after that, D, transitioning to a new state based on the current state and symbol read. Next, A, writing a symbol onto the tape. B, moving the tape head left to right, and at the last what we do is halting and checking, accepting or rejecting the input. Okay, C, D, A, B is your pattern. Okay, which of the option follows this is your option C. So your correct answer is answer C. Let's move on to the next. Okay, again match the list, counter is there and their uses or working we need to match with. Okay, so let's find the pattern. Okay, so first we have n-bit ring counter, synchronous counter, asynchronous counter, and decimal counter. Okay, so I guess the easiest one to guess is here is decimal counter that counts from 0 to 9. Okay, so D goes for 3. Let's try to eliminate. D goes for 3. Okay, there are 3 options, only one gets eliminated. Let's check for the other easiest one. Okay, synchronous counter. Okay, this is a universal clock. Okay, synchronous counter is also known as what? Universal clock. Okay, so B goes for first. Okay, B goes for first. Let's try to eliminate. Okay, these two have B for first. This also gets eliminated. Okay, now, and what is n-bit counter? N-bit counter basically counter that circulates single 1 or 0 bit around a ring of n flip-flops. Okay, it counts exactly n states. Okay, so this matches with this your option, that is option number 2. Okay, and lastly your asynchronous main clock is applied to first flip-flop only. Okay, so your C goes here. Okay, so A goes for A goes for 2, right? So A goes for 2, B goes for first, that is synchronous counter is universal clock. C, asynchronous counter is applied to first flip-flop only, and D, decimal counter counts from what, 0 to 9. So your option C is your right answer. Okay, the answer is option C. Let's move on to the next. Okay, so next what we have is arrange the following stages of parsing in correct order as they typically occur in the compilation process. Okay, during the compilation process, parsing is done. Okay, so what is the correct process of it? Okay, so options are given: lexical analysis, semantic, syntax analysis, IC generation, and code optimization. Okay, so first is correct, first option. It is a lexical. First we do a lexical analysis, then we do syntax analysis, not semantic. First we do syntax analysis, then we do semantic analysis. Okay, after that we do what? intermediate code generation, and at the last we do code optimization. Okay, so your correct pattern will be option A, lexical analysis, then option C, syntax analysis, then option B, semantic analysis, then option D, intermediate code generation, and then option E, that is your code optimization. Correct pattern is A, C, D, D, E. So which option follows this? Okay, the option number B follows this, that is your right answer. Okay, answer B is your correct answer. Let's move on to the next. Okay, so how does question number 14, how does a relational database ensure data integrity? Okay, database related question. How does a relational database ensure data integrity? By encrypting all data stored, by enforcing rules defined in the schema, by compressing data, by allowing unrestricted access to all user. Okay, this is straight away not a valid statement in any case. Okay, so we eliminate this. Now, by compressing data for efficient storage, can we ensure data integrity? No. So this also gets eliminated. By enforcing rules defined in the schema, yes, we can maintain data integrity using this. By encrypting all data stored, no. Okay, so your correct answer is option number B. By enforcing rules defined in the schema, we can ensure the data integrity in relational database. Okay, so your answer is answer B. Let's move on to the next. Okay. Which of the following best describes the structure of relational database? Data organized into table with rows and columns. Data organized into files and folder. This is straight away wrong. Data organized in hierarchical tree structure. This is also wrong. Data organized into network of interconnected nodes. This is also wrong. So your only correct answer is option A. That is data organized into tables with rows and columns in a relational database. Okay, so your option A is your right answer. Let's move to the next. Okay, you might be getting this easier question, few easier question as well in your examinations. Okay, so let's move on to the next. Okay, next we have code output related question. Okay, so swap function is there, reference variables are there. Okay, int x and int y, and swapping is done. Okay, swap function. Now in the main function, what we have, we are calling integer a and 5 and 10. First we call as swap ab, and again we have called what, swap ab. So what will be the output? Okay, what will be the output of the following code? Okay, so first when you first call your swap function for the first time, that is a comma b, then a value was a value was 5, b value was 10. After this first swap, a becomes 10 and b becomes 5. Once again we have called what, swap function. Okay, swap a comma b. So again the swapping is performed, so again a becomes 5 and b becomes 10. So your correct answer should be 5 comma 10, that is your option number A. Answer is answer A, option A. Okay, let's move on to the next one. Okay, which of the following are context free language? Okay, from the following, which are the context free languages? Okay, so let's see one by one. So first one, if you see the pattern, the language is context free. It can be generated by a context free grammar. For instance, we can create a grammar. Okay, for this one, first one. Okay, we can create a grammar that generates string where the number of w's that we have, okay, the number of w's plus the number of y's equal to the number of x plus the number of z, x plus the number of z's. Okay, so this is a context free language. Next, if we see this one, okay, this is also a context free language where we create a context free grammar where w and x are generated together. Okay, so this is also a context free language. Next, C1. Okay, if you observe closely, k not equal to 1. Okay, and the pattern is given I equal to j equal to k. Okay, so this is not a context free grammar because the constraint I equal to j equal to k imposes a condition that requires counting and comparing three separate counts. Okay, how many? Three separate counts, which cannot be achieved by a context free grammar. So this is not a context free language. Next, you have D. Okay, again here the condition I equal to j equal to k plus 1, again the same as above in option C. Here the same issue is there. The condition I equal to j equal to k plus 1 requires a more complex relationship that cannot be captured. Okay, so this is also not a context free. And last, what we have, similar to C, we have a condition I equal to j equal to 1. Okay, are too complex. Okay, this is the also too complex for context free language. Okay, so your only option A and B are correct. Okay, and from the given option, okay, your correct answer is option number A, and only two statements are right, that is statement A and statement B. So correct answer is answer A. Let's move on to the next. Okay, let's start with our question number 18. Okay, what is given? Base class is there. Okay, having a base class constructor and the base class destructor. Okay, mentioned as virtual. Then class derived class is there, extending base class. Derived class has its own constructor and a destructor. Okay, and using the base class pointer, we are calling the new. Okay, so what it's done, base class. Okay, pointer we have, and we are referencing to what, derived class. Okay, derived class. Okay, so as soon as you do this step, okay, we need to predict the output of the following statement. What will be the output as soon as we do this? Okay, so since the constructor of base class is executed first, okay, so your first statement that will be executed is base class constructor. Okay, then the constructor of derived class is executed. Okay, after this, then the constructor of derived class is executed. Okay, so your second uh, continuation statement will be derived constructor const, derived const. Okay, so from the option you can just eliminate. Okay, so derived const base constant. Okay, this gets eliminated straight away. Okay, then we have three options left with the same pattern. Next line is given delete b, delete b. So once we call delete b is called, it triggers the destruction process. The destructor of derived class is called first. Okay, why it is called first? Why the not the base class destructor? As you have studied the change of chain of constructors or chain of destructors, the base class constructor or destructor should be called first. But why it is not called first here? Because here we have mentioned virtual keyword. Okay, so your first output will be derived class destructor. Okay, so base class constructor, derived class constructor, then derived class destructor. Okay, so this option one is matching your pattern. Okay, so this derived class destructor will be the third one that gets executed, and after that your base class destructor will be called. Okay, so your option first matches the output, and which is your right answer as well. Okay, so answer A is your right answer for this particular question. Let's move on to the next. Okay, next we have transactions and schedules. Okay, so consider the transaction T1, T2, T3 and the schedules S1 and S2 given below. Okay, so transaction T1, it says what, read one. Okay, and read read one X. Okay, read one Z. Okay, and write operation. Again there, T2 transaction R2Y, R2Z, W2Z. T3 transaction R3Y, R3Z, X and W3Y. Okay, and schedules are given. Okay, schedules are given here. Okay, so let's first pen down transaction T1, T2 and T3. Okay, so first statement or first that has been done or is schedule number one, and that is done what, first transaction one, what we are doing is reading. Okay, reading X, then T3 reads the X, right, sorry, T3 reads Y. Okay, here focus here, this, S1 schedule, R1X, R1Y. Okay, then T2 is there, read X, read RY, RZ. Then we have transaction 3, WI, WZ. Then transaction 1 we have R1Z, and then we have W1X, that is WX and WZ. Okay, so proceeding the graph, there is no loop in S1. If you see, there is no loop or conflict in no loop in S1, so it is conflict serializable. Which one? S1. Okay, let's see for the schedule 2. R1, let me erase this first of all. For S1 we have done. Okay, then let's check for S2. Okay, let's check for S2. Okay, so the schedule is what? R1X, so RX here. Then we have RY, R3Y means RY, T3 transaction. Then we have RY here, T2 transaction. Then we have RX here, T3, R3X, right? Then we have R1Z, so it goes again back to transaction 1. Then we have RZ again with transaction 2. Then we have WY with transaction 3. Then we have WX transaction 1, WZ transaction 2, and WZ again with transaction 1. Okay, so the precedence of the graph, if you see, we are looping here. Where we are looping, if you draw it in the graph, T1, T3 and T2 for serial schedule 2. Okay, so we have started with what? T1. Okay, and we in between transaction 1 and transaction 2 we are looping. Okay, we are looping. Okay, there is a loop between transaction 1 and transaction 2. So since there is a loop in S2, so S2 is not a conflict serializable. Okay, so only one S1 is conflict serializable, so your answer should be option A, that is answer option, only S1 is conflict serializable. Okay, let's move on to the next. Okay, what will be the output? Let's predict the output of the following code. Okay, first of all, you should be able to understand the pass by value and pass by reference. Okay, so let's analyze this code. First is initialization. Okay, in the main, if you see, let's start with the main. Okay, character pointer is there, which is initialized to 1, and character B pointer is there, that is initialized to 2. A initializes A to point to the string 1. Okay, basically what will happen, A will be pointing to string 1. Okay, and B's pointer will be pointing to 2. Okay, I hope this is clear. Okay, now function f1 a comma b. So what happens when we call function f1? Okay, we are calling what? Function f1 a comma b. Okay, then with a and b passed, okay, by value, okay, the pointer themselves are copied. Okay, the here we are copying, we are doing what? Creating a copy. Okay, so here if you see, this is done what? A swapping is done. Inside f1, the local variables x and y are set to values of a and b. The swapping occurs, but it affects the local copies, that is x and y. It affects only x and y. Okay, and it does not affect the original a and b values. Therefore, the a and b remains unchanged. Okay, so once you start printing this, print a comma b, then your output will be same, 1 and 2. Okay, so 1 and 2 will be the same, so the other option we can eliminate. These and these are wrong one. Okay, let's try, let's see the second function for f2. In f2, again we are passing what? We are passing reference. Okay, we are passing reference, so any change in this will affect the original value. Any change in this will affect the original value. Again we are doing what? Swap. So A becomes 2, A becomes 2, A becomes 2, and 2 becomes and B becomes 1. Okay, so if now we print this particular statement, then the output should be 2 and 1. Okay, so first your output will be F1 will be 1 2, and F2 will be 2 and 1. Okay, so your correct answer for this particular question is answer A. Always remember the difference between pass by value and pass by reference. Pass by value creates the copy of your variable. Pass by reference, whatever the changes will be done will be reflected on your original value, original variables. Okay, whether it is pointer or whether it is your normal variable. Okay, so your answer A is your right answer. Let's move on to the next. Okay, next we have, which of the following statements about pointer in C are true? Okay, which of the following statements are true? Let's check one by one. Pointer can be used to access array elements. Yes, it is true. Pointer can store the address of another pointer. Yes, it can be another pointer, it can be variable. Okay, this is also true. Pointers are automatically differenced in expression. Okay, automatically difference? No, this is not a correct statement. You should explicitly use asterisk operator to access the value. Okay, so dereference meaning accessing the exact value, meaning referencing the member. Let's say you have a pointer P. Okay, so if you want to know the value or at this, so you need to use the asterisk. Okay, so explicitly know what value is stored at that particular location. So this is wrong. Pointers cannot be used to access structure members. Okay, this is also wrong, because pointer can indeed be used to access members of a structure. Okay, using for example, if you have a structure like this truck, let's say any structure. Okay, just a name, int x, and your structure ends. Okay, so you can create something like a pointer to structure like this: structure, then your structure name, that is here is any, and your pointer. Okay, let's say asterisk ptr. Okay, you can create that. Okay, and now you can access a x, this variable structure date member of a structure, using pointer, using this. How you can access? Using this. Okay, ptr then x. Okay, you can access this. Okay, so this is also wrong. So your correct answer is A and B only, that is your option B. Okay, let's move on to the next one. Okay, which of the following are agile process models? Okay, from the software engineering models. Okay, software process models, which are the following are the agile process model? Okay, extreme programming, yes, this is agile process model. Waterfall, straight away no. Standard software process model it is. Scrum, yes, Scrum is a agile process model. Spiral, no. Okay, and incremental, no. Okay, so your correct answer is A and C only are the agile process model. Okay, so your option A is your right answer for this particular question. Okay, that is extreme programming and Scrum are your agile process model. Let's move on to the next. Okay, which of the following statements are true about mutual exclusion in concurrent programming? Okay, let's identify which one are the true and which one are the false one. Mutual exclusion ensures that only one process can be in a critical section at any given time. Yes, this is right. The major fundamental core core idea of mutual exclusion, it ensures that only one process can be in critical section area. Okay, mutual exclusion are designed to prevent conflicts and ensure that only one process can access shared resource at a time. This is also a true statement. Okay, at a time only one process can access the shared resource. Mutual exclusion can use various algorithms to ensure that process do not enter the critical section simultaneously. Right, at a time only one can be entering. Okay, so this is also right. Mutual exclusion allow multiple processes to access the critical section simultaneously straight away. This is wrong. Okay, so your correct answer are A, B, C only. That is your A, B, and C are right. D1 is wrong. Okay, so option A is your right answer for this particular question. Let's move on to the next. Okay, now testing type and their description. Okay, unit testing, integration testing, system testing, acceptance testing. Okay, so at least minimum two you should know to apply the elimination process. Okay, unit testing is basically where we are testing the individual components. Okay, so this straight away goes for the first one. Okay, here testing individual components of the software. Integration testing is where we are combining the different components. Okay, we are combining the different components and testing the how the integration has been done. Okay, how the integration works well or not. Okay, so here testing the interaction between integrated component. Okay, straight away here it goes for second. Now let's try if we can eliminate. For A goes for first and B goes for second. A goes for first is everywhere, B goes for second is at two places, so these two gets eliminated straight away. System testing. System testing is to check the complete system. Okay, is to check what the system. Okay, complete system to ensure. Okay, to ensure what, to ensure if it meets the requirement. Okay, so here it goes for C. Now acceptance testing. Acceptance testing is basically what, to verify whether the system that we have developed actually meets the requirements that were laid down. Okay, so your option 3, that is acceptance testing, is to test to verify system meets the business needs. Okay, so let's see which pattern. A goes for first, B goes for second, C goes for fourth, and C goes for fourth and D goes for third. So option B is your right answer. Option B is your right answer. Okay, so let's move on to the next one. Yeah, next we have is, given a project with an estimated effort of 1500 person hours and a team of 5 peoples, how many days will it take to complete the project if each person works 8 hours a day? Okay, an estimated effort is given. Okay, what is the estimated effort here given? Okay, calc estimated effort given is what, 1500 per person hours is given. Okay, this is the estimated efforts. Okay, so first of all we will calculate the total number of hours the team can work per day. Okay, how many people are there? 5. Okay, each person works how many hours a day? Each works 8 hours a day. Okay, so the entire team output in a single day is 40 hours. How much? 40 hours. Okay, now to calculate the number of days required to complete the project, okay, the total hour efforts is what? 1500, and in a single day what we are covering is 40. Okay, so straight away you will just divide this to get your answer. Okay, 1500 is the estimated person hours required. Daily we are delivering what? 40 hours. So straight away if you cancel this, okay, 3 sevens are, okay, 4 threes are 12, right? Then we have 7, then 0.5. Okay, your answer will be 37.5 days will be required. Okay, that is the option number B is your correct answer. That is 37.5 days will be required to complete the project. Okay, so answer is B. Let's move on to the next one. Okay, we have again matching list. Some scheduling algorithms are given and their respective characteristics. So let's try to first go with the elimination process, and you should know me easiest one first. First come first serve, first serve, FCFS is what? Processes are executed in the order they arrive. Okay, as soon as the process arrive in the sequence they are executed. So here processes are executed in the order they arrive. So option 3 goes for A. Option 3 goes for A. Let's try to eliminate. Okay, option A goes for 3. So this first two gets eliminated straight up. Now next, shortest job first. Basically the process is selected for execution with smallest burst time. Okay, smallest what? Smallest burst time. Okay, so this B goes for 4. Then round robin. Okay, this ensures a fair chance. Okay, this ensures a fair chance where estimated a proper, let's say there are 5 process, each process will be given a 5 second or 2 second, then the next process turn will be there. Okay, so C goes for second, and last priority scheduling, straight away each process is assigned a priority. Okay, so if you see A goes for third, B goes for fourth, C goes for second, and D goes for first. So this is your right answer, that is C. Option number C is your right answer. Okay, let's move on to the next one. Okay, let's see the next. Okay, host A on TCP IP4 network sends an IP datagram D to host B also on TCP IP4 network. Okay, there is a host A that is using IPv4 network, and host B. Host B is there, that is also using IPv4 network. Okay, assume that no error occurred during transmission of D datagram when D reaches B. Okay, when this particular D datagram reaches to host B. Which of the following header field may differ from that of original datagram D? Okay, so it is basically asking which of the fields may differ. Okay, or which of the fields changes during this particular transfer. Okay, now, so first let's check what are the field given. TTL, time to leave. Yes, the time to leave field is changed. Why? Because it has been decremented by each router the datagram passes. Okay. Next, checksum, the IP header checksum will change as the packet travel the network. Okay, so this will also change. Next is your fragment offset. If the datagram was fragmented during transmission, the fragment offset field may change. Okay, so these might also change. Next, source IP, will it change? Basic, fundamental, will it change? No. Destination IP, will it change? No. Okay, so your only option A, B, C will change. That is your option number B is your right answer for this particular question. Let's move on to the next. Okay, arrange the following step in a correct order to solve knapsack problem using dynamic programming. Okay, we need to arrange the sequence for how we solve a knapsack problem in dynamic programming. Okay, so the steps are given: define the base case, compute the maximum value, identify subproblem, initialize a table, iterate through each item in the possible capacity to fill the table. Okay, so let's do one by one. Define the base case with when the capacity is 0 and no items are left to be considered. So this is the first step. Next is identify subproblems and the dependency based on weights and values. This is the second step. Third step is initialize this table to store result of subproblems. Next, fourth is iterate through each item and each possible capacity to fill the table. And last, compute the maximum value that can be obtained using items up to the ith item and a knapsack capacity of 0. Okay, so the correct sequence will be A, first define the base case where the capacity is 0, no items left. Then second, and that is C. Okay, identify subproblems and the dependencies. Then initialize a table to store the results of subproblem, that is option D. Then iterate through each item. Okay, and see for possible capacity to fill the table. Then uske baad, okay, fifth is your option number B, compute the maximum value that can be obtained using each item. Okay, so the correct pattern is A, C, D, E, B. A, C, D, E, B. That is the option number C is your correct answer for this particular question. Okay, answer C is your correct answer. Let's move on to the next. Okay, next question number 29. Consider a three-way handshake process followed during TCP connection establishment where two hosts, host A and host B is there. Host A and host B. Let S and R be two random 32-bit starting sequence chosen by A and B. Okay, both of them chooses what? 32-bit sequence. 32-bit sequence. Okay, I am writing this because the text is little bit smaller. Suppose A sends a TCP segment having SYN bit equal to 1, sequence number equal to S, and acknowledgement equal to 0. Okay, so SYN, okay, equal to 1, sequence number is S, and acknowledgement bit is 0. And B accepts the connection request. B accepts the connection request. Which of the following choices represent the information present in the TCP segment header that is been sent by A to B? Okay, which of the following choices represent information is present in the TCP segment? Okay, if it contains the information or not. Okay, so correct answer is your answer number C. Okay, now we will analyze this as well. Sync bit is 1, sequence number equal to R, acknowledgement acknowledgement bit equal to 1, acknowledgement number is equal to S plus 1, pin bit equal to 0. Okay, so this will give, okay, what the information present in the TCP segment header. Okay, so first of all you should know what are these bits. Okay, so pin bit is set while terminating the connection. Okay, pin bit is used for what? Pin bit is used for terminating the connection. Sync bit is used for initiating the okay, SYN bit, okay, is used for what? Initiating the request for connection establishment. Okay, so meaning your connection is established because here it is 1. Sequence number in TCP used for counting each byte transferred in particular connection and each segment header. Okay, first part of byte of data. So if this is there, meaning information is present in the header, right? Straight away acknowledgement bit equal to 1. Okay, see why not this and this, I will tell you. Here sync bit is 0. Okay, so straight away connection isn't established, right? Now here acknowledgement number equal to S plus 1. Okay, meaning that indicates the sequence number of bits expected next. Okay, so meaning the information has been transferred. Okay, so answer, your option C will be your right answer for this particular question, that is answer C. Let's move on to the next. Okay, next we have software design principle and their definition: cohesion, coupling, abstraction, and modularity. Okay, so let's start with the simplest elimination technique. What is abstraction? Simplifying complex reality by, okay, okay, now what is abstraction, what is modularity? Okay, this you should know. Okay, so let's start with abstraction itself. Okay, what we do in abstraction, basically we simplify complex reality by modeling classes appropriate to the problem. Okay, so this will be C. Option C goes for option 4. Here A, cohesion, degree to which elements of a module belong together. Cohesion means togetherness, right? So A, sorry, here A will be there. Option 3 will be A. Next, coupling. Coupling is what? Degree to which module relies on another module. Okay, so this goes for option D. Next, modularity. Dividing a software system into distinct modules is known as what? Modularity. Okay, so A goes for 3. Let's see where A goes for 3. Okay, these two gets eliminated straight away. B goes for first. Okay, B goes for first. So this is your correct pattern. That is your option number C is your right answer for this particular question. Okay, let's move on to the next. Okay, let's start with the question number 31. Okay, we need to predict the output of the C program. Okay, program is given where we have int x. Okay, array is given 2, 4, 6, 8, and 10. Okay, then we have two integer variables initialized with 0, and we have a pointer. Okay, now asterisk y equal to x, meaning it is pointing to x array. First of all, it is pointing to x array, but plus 4 is given, so it will be pointing to fifth element. So 1, 2, 3, 4, 5. So your y is pointing here. Okay, remember this. Next, we are having a for loop. A equal to 0, a less than 5, and a plus plus. Okay, so let's solve this for a equal to 0. When a equal to 0, Okay, then what will be the case? B is already 0, right? First case, first iteration. So B equal to B plus asterisk Y minus A, okay, minus asterisk Y minus A. Okay, so we know B is 0. We know asterisk Y where it is referring to the value 10. Okay, so 10 minus A, what is the A value? 0, right? Minus. Now this asterisk Y minus A, your Y is 10, A is 0, right? Now this Y is address. This Y is what? Address. That is pointing to X of 4, your fifth element. Your fifth element. And you are minusing 0, meaning what? It is nothing but what your x4 element. Okay, now it is like this value at x of 4, value at x of 4, that is nothing but 10, that is nothing but 10. So this evaluates to 0 plus 10 minus 10, 0. Okay, 10 10 will be cancelled, so your B will be 0 for the first step. For what? For the first step. Okay, next. Now only remember this remains same. This your first part remains, this remains same, only A values changes. So again, so for A equal to 1, B is what? B is 0, right? 10 minus 1. Why? A is now 1. Minus asterisk. Now x4 it was. Now it will reference to what? X of 3. X of 3. So what is your X of 3 now? Now your X of 3 is what? 8. Okay, so this 9 minus 10 minus 1 is 9, 9 minus 1 is 8, so you will get 1. Okay, now B gets added up, so B is equal to B plus 1. Now B becomes 1. Okay, so accordingly if you perform, okay, so let's go for what? Go for A equal to 2. Again same. Now you have B equal to 1 plus 10 minus 2. Okay, then X of 2, right? I will write the steps. 1 plus, okay, now your B becomes what? 10 minus 2, 8, right? And your X of 2 is what? 6. So 6 minus 8 minus 6 is 2 plus 1, 3. So your this becomes, B becomes 3, and this is for A equal to 2. Accordingly, if you do till A is less than 4, you will get the value as B equal to 10. B equal to 10. Okay, I hope you get the concept here. Here y asterisk y is referring to the value 10. Here this part is referring to x of 4, and this goes on decreasing till x of 0 value straight away. Okay, this is how it is resolved. Okay, so your correct answer for this particular question is option number D, that is 10. Answer is D, that is 10. Okay, let's move on to the next. Which of the following statements are true about privilege instructions? Okay, so first of all you should know what are privilege instructions. Okay, privilege instructions, let's see the definition itself. Privilege instructions are designed to be executed only by the operating system kernel, okay, not by a user application. So let's go the statements one by one. It can only be executed by operating system kernel and not by user application. Just now I have said, okay, so this is the true statement. Okay, next, it is designed to perform operation that can directly affect the hardware or software state, such as IO operation or changing memory management setting. Yes, this is also true about privilege instruction. User application can execute privilege instructions if they have to correct permission set by operating system. No, just now we have said it cannot be used, cannot be executed by user application. It is usually executed in user mode to ensure the safety and security of the system. No. So if you know the definition, straight away these two options get cancelled out. Okay, so your correct answer is what? Only statements A and B, that is your option number A is your right answer for this particular question. Okay, let's move on to the next. Okay, which of the following are typical activities in software process lifecycle? Okay, so what are the liable steps you can say? Okay, typical steps in software process lifecycle. Requirement analysis, yes, it is a proper step. System design, yes. Code refactoring, no. Deployment, yes. Substructure, no. Okay, so A, B, and D are the correct, or you can say the valid activities in software process lifecycle. That is your option number C is your correct answer for this particular question. Let's move on to the next. Okay, so now we have queries and the respective probabilities are given. So we need to do this matchup. Okay, so first we will go with the very simplest one. Okay, let's say in a pack of 52 card, one card is drawn at random. What is the probability that it is either a king or a queen? Okay, so there are four kings and four queens. Okay, now this type of question is basically used to waste your time. Okay, you can check four probability question as, and that too as a match list. Okay, so anyways, so in a pack of a card there are four kings and four queens. Okay, in a pack of 52, the total number of favorable outcomes, that is 8 out of how much? Out of 52, out of 52, right? So it is what? 2 by 2 by what? 2 by 3. It is what? 2 by 3. If you see this, okay, just a second. I hope options are correct. Options, okay. We have 3 by 6. Okay. So if we try to cancel by 2, okay, this becomes 26. This becomes 4. This becomes 2, and this becomes 13. Okay. So 2 by 13 will be viable option. This is the right option. It should be 2 by 13 here. Okay, so your option B matches to your option 3, option number 3. Okay, now let's try to eliminate. Okay, option B matches to third one, so this two gets eliminated straight away. Okay, always in this case try to solve the probabilities, those are simple ones. Okay, next let's try again some another probability. Okay, let's take the first one itself. Total number, a bag contains 6 white and 4 red balls. Two balls are drawn at random. What is the chance they will be the same color? Okay, so it is what? Total number of 2 out of 10 balls we have to take. 2 out of 10 balls, right? So C, how we can give C 10 comma 2. Okay, so if you calculate this, you will get 45. Now, the number of ways to draw two white balls is what? C 6 comma 2. Why? Because the number of white balls are 6. Okay, so this is 15. Now, to draw the number of two red balls is what? 4 comma 2. That will come as 6. Okay, now the probability of drawing two balls of the same color is what? Two balls of the same color. Okay, so either I will be getting two white balls or either I will be getting two red balls is 15 plus 6, comparison of both. Okay, divide by 45 out of 45. Okay, so that is 21 by 45, and if you do that, okay, 7 3 is a, okay, okay, so it will 3 sevens are, okay, 3 15s are 7 by 15. Okay, so option A 7 by 15. So this goes for option A. So let's check. Option A is 4. Yes, in this both the pattern option A is 4. Let's check for the one last, then it will be solved. Option C, a bag contains 6 red and 6 red, 4 white and 8 blue balls. Okay, let me erase this so that we can have this one solution as well. Okay, so option number C we are looking, right? So a bag contains 6 red, 4 white and 8 blue balls. 6 red, 4 white, and 8 blue balls. Okay, so this is what option number C. So if three balls are drawn at random, find the probability that three balls are drawn at random. Okay, find the probability that one is red and two are white. Okay, so the total number of ways that we can draw the three balls out of 18 is what? Okay, total number of balls are 18, right? 6 plus 4 plus 4 plus 8. So three cards out of 18 is what? C, 18 comma 3, right? That will give you 816. Okay. Next, number of way to draw one ball, one red ball is, how many red balls are there? 6. So it will be what? 6 comma 1. That will give you 6. How many possibilities we can do of white? Okay, total 4 white balls are there. We are removing 2. So we want 2. So C 4 comma 2. Right. So this will give you a 6 as well. Now probability is what? How to find the probability for what? One red ball and two white balls. So it will be straight away 6 into 6, this 2 multiplication divided by the probability of picking up the 3 cards. 3 balls, 8, 1, 6. Okay, so that will go as 36 divided by 186, which is nothing but 3, 9 3 is a, sorry, this 12 3 is a 36, and this will go as 6, and this go as 8. Okay, 3 by 68. Okay, which is your option number 1. Okay, so C goes here. Okay, so out of this you can mark your last option, that is option D is your right answer for this particular question. Okay, so you can see how much time we have took this for this particular question. Okay, where we need to solve at least 3 probability. Okay, so make sure you attend this at last. Okay, that is also fine. Okay. Okay, so for this, the correct answer is option number D. Let's move on to the next. Okay, select the sorting algorithms that are stable. Select the sorting algorithms that are stable. Now, one by one, we will see quick sort. Is it stable? No, it is not stable because it does not guarantee the relative order of equal elements that will be preserved. So this is not stable. So quick sort is incorrect. Bubble sort, yes, it is a stable sorting algorithm because it compares and swaps adjacent element, thereby preserving the relative order. Okay, it maintains the order. Okay, so it is one of the stable algorithm, sorting algorithm. Next, insertion sort, yes, this is also a stable one. Why? Because it inserts element into the correct position without changing the relative order of equal elements. Okay, so this is also a stable one. Merge sort, it is often implemented as stable, but it is not inherited stably. It depends on the implementation. Okay, it kind of a maybe situation, but not fully stable. Okay, last, self sort, it is not a stable sorting algorithm because it can move element far distances, potentially altering the relative order of equal elements. So this is also wrong. Okay, so your correct answer is only option B, bubble sort, and option C, insertion sort. That is option number C is your right answer for this particular question. Okay, question number 35. Okay, let's move on to the next. Which of the following is the correct way to declare a functional pointer in C? Okay, out of this, what is the correct way to declare the functional pointer? Okay, so functional pointer, that is function pointer, is what you declare for a function pointer in C. The correct syntax must be followed is your data type and pointer, then your function name, that is f name, and then data types, parameters. Okay, so this is the basic syntax for it. Okay, so and this goes like this. Okay, in this bracket. Okay, so out of this, your option B is your right answer. Okay, that matches this particular pattern. Okay, so this is how we declare what. See, straight away, this option D is wrong, not a valid. Option C is also wrong because nothing like this we do in C programming. From this two option, you need to specify in parenthesis when we are declaring a functional pointer. Okay, so your option B is your right answer for this particular question. Let's move on to the next. Okay, a coin is tossed successfully 3 times. Find the probability P, event E, sample S of getting exactly one head or two heads, where N is the number of occurrences. Okay, so again probability. Let's see. Sample size S is given. Okay, so N of S we know what it is. A coin is tossed 3 successful times, then N of S is what? 8. Right. Now the event, what the event is given? Event E. Event E is given what? The event of getting exactly one head or two heads include the outcome. Okay, so let me first of all pen down what is S here. S is what? Let's say H, 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 T, head, head, tail, then head, tail, head, then head, tail, tail, then tail, head, head, then tail, head, tail, then tail, tail, head, then tail, tail, tail. Okay, all this possibility, that is N of S equal to 8. Now the event that is mentioned is one head or two heads. Okay, one head or at least one head or two head is there. Okay, so you can find. Okay, so this gets eliminated. Okay, and your one or two heads, so this also gets your eliminated. Why? It is mentioning only exactly one or two heads. Okay, so total 6 possible events are there. Okay, so N of E will be 6. Okay, understood. Next, probability. What is the probability of an event is given by the ratio of favorable outcomes. Okay, favorable, that is we know that P of E is basically given as N of E divided by N of S, right? So that is what? 6 by 8, that is equal to 3 by 4, right? So let's now evaluate the options. Okay, straight away first one, the statement is not correct. N is given what? NS is 8, this is fine, but N of E is given 4, so this is incorrect. This is correct, just now we have seen. P of E is 3 by 4, this is also correct. P of E is 1 by 2, this is incorrect. So your option B and C are right. Nice. Okay, so your option B is the correct answer for this particular question. Okay, let's move on. Consider the grammar. Okay, we have grammar is given. Now to determine how many see, if I is the closure, then how many item be in the set of go to. Okay, close set is given. So to determine that, so first step is to compute the closure. Okay, that is I0 we need to calculate first of all. Okay, so first of all, from S to A, from S to A, we look for productions of A. Okay, so A is what? This. Then we have A to ID. Okay, so we add something like this. Now we have B productions as well, that is B goes for, this is B, B goes for A, right? And B itself is B. So then the closure, the overall closure will be having how many elements? See, B is also going for B comma A, right? So the number of elements or items will be, first you can uh, consider, first that you can consider is S A, second A dollar B dollar, third A to ID, fourth B to B comma A, and fifth B to A. Okay, so how many total items we have identified? We have identified sorry, Extremely sorry. Okay, so we have identified how many items? We have identified 5. So option C, sorry, your option, uh, sorry, your option C is your right answer. Okay, option C is your right answer. Let's move on to the next. Okay, we have given a schema. A relational schema is given where R equal to, okay, U, V, W, X, Y, Z, on which the functional dependencies are also given. Okay, you can see the functional dependencies. Okay, now the candidates, it is asking for the candidate key, okay, of R, of the relational schema R. Okay, so what is candidate key? Basically, a candidate key is a column or a set of columns in a table that uniquely identify any database record without referring to another data. Okay, so the following functional dependencies, if we see, is what? Okay, so first we have is U to V, right? Then we have VW to X, Y, W, and X to U. Okay, so here if you see, YZ is a independent key. YZ is what? YZ is a independent key. So for every key, the Y set should be there. Okay, for every key, what? Y and Z should be there. Okay, so the so check for the option where YZ of keys are there. YZ keys are there. Okay, so if you check all the options, you find option D has all the keys containing YZ option. Okay, so your correct answer for this candidate keys that you can have is UYZ, VYZ, and XYZ. Okay, so your option D is your right answer. Okay, there is alternative method also to do it, but we will prefer this one as well. Okay, so let's move on to the next one. Okay, again schema related question. In a schema R, A, B, C, D, E, F, G, H, each field of R contains only atomic values. Okay, atomic values. Functional, this is given. Okay, functional set of functional dependencies is also given, so that F closure is exactly the set of FDs that holds R. The relational is in. Okay, so first of all, you should know what is set functional dependency. A functional dependency is a relationship or dependency that exists between two all attributes. Okay, and closure means the complete set of all possible attributes that can be functionally derived from the functional dependency. And normalization, you know, normalization is used to minimize the redundancy from a set of relations. Okay, so according to the given dependencies, what we have, CH goes to G. Okay, A to B, C, B to C, F, H, E to A, and F to EG. Okay, so since D is not the part of it, any functional dependency, so it can be a candidate key or maybe a part of candidate key, D. Okay, so to find more candidate key, okay, we can add A, B, C, D, E, F, uh, E, G, H to D and find its closure. Okay, like this. A, D closure, accordingly B, D closure, okay, and so on. ED closure and FD. Okay, so but the dependencies are partial dependency. If we say A is to BC, B is to CFG, and F is to EG, these are what? Partial dependencies. Here C, H, C, H, and G are what? Non-key attributes. Okay, so this with this we can conclude what the given relation is, what is in 1NF. It is in what? 1NF, where we don't have atomic value, but it is not in 2NF. It is not in what? 2NF. Why we say this? Because if a relation is in 1NF, and 2NF is only possible when all non-key attributes are fully functionally dependent on the primary key. But here these keys CGH are dependent on what? Are dependent on your partially dependency is there. Okay, it is not fully dependent. Okay, so the given schema is in what? In 1NF but not in 2NF. So your answer A is your right answer. Okay, let's move on to the next. Okay, so question number 41 we have. Okay, statement is given. Let X, Y be the statement X loves Y, where the domain of for both X and Y consists of all people in the world. Use quantifiers to express joy is loved by everyone. Okay, we need to express this. Okay, so to express joy is loved by everyone, predicate LXY. Okay, we are predicating LXY means X loves Y, right? So we want to convey that every person X, that for every person X, that person's love joy. That person's love what? That person's love joy. This can be expressed as follows. The universal quantifier is as follows. Okay, this X L X comma joy. Now what this translates to? This translates to for every person X, X loves joy. Okay, which accurately indicates that everyone loves joy. Okay, so from the given option you can take mark your right answer, that is option number A is your correct answer. Okay, let's move on to the next. Okay, the grammar is given here. Consider the grammar. Okay, X here X, Y, Z are terminals and T, Q, R, S are non-terminals. What will be the following set of non-terminal R? Okay, what will be the following set of non-terminal R? Okay, so these rules are given. Let's say first of all identify rules that are involving R. Okay, so Q, R, S is there, meaning R appear before S, and we need to determine what follow S. Okay, so determine follow set. Check for Q. Let's check for Q. Q is here. Okay, so from T we are going to QX. Okay, the follow of Q includes X. Okay, so we can conclude what? Follow of Q equals X. Okay, so from QRS the symbols that follow R are the symbols in the follow set of S. In the follow set of what? In the follow set of S. Now let's determine the production for S. So S produces what? Z and epsilon. Okay, we consider S in Q. Okay, so to create the follow of S, the symbol that can follow S include the follow of Q, which is X from T. So we can state follow of S is nothing but same as follow of Q, that is X. Okay, so this is one. Now if we combine the results, okay, so follow of X, follow of X, see, since Z was already there, so follow of X will be what? Will be follow of S will be terminal Z and X, terminal Z and terminal X. Okay, so your option that matches this is option number C is your right answer for this particular question. Okay, let's move on to the next. Okay, next what we have, Consider the following statements regarding combinational and sequential circuit. Okay, so you should be aware what are combinational and sequential circuits. So let's check the option one by one. The output of combinational circuit depend on only the current input. Yes, okay, only on current state, not the memory based. Next, output of combinational circuit depends on both current and previous output. No, wrong. Output of sequential depends on the current input. No, it depends on the previous one. Output of previous and output of sequential circuit depends on both current and previous output. Yes. So only option A and D are right. That is your option number B is your correct answer for this particular question. Next, a CPU has a 5-stage pipeline with the following stages: fetch, decode, execute, memory, and write back. Each stage takes one clock cycle to complete. Assume that there are no pipeline stalls and the pipeline is initially empty. How many clock cycles are required to complete the execution of 10 such instruction? Okay, so let's break down. Okay, what are the stages here? F, that is fetch, decode, execute, memory, and write back. Okay. After the pipeline is filled, every subsequent instruction will be completed in one additional clock cycle because stages work in parallel, right? Okay, they go in parallel. So for first instruction takes 5 cycle. Okay, so it will go in this way. Let's say F, D, E, M, W. Okay, 5 stages. So for first instruction it takes 5 cycle, right? How many cycle? 5 cycles. Okay, 5 cycles. Okay, because 5 stages. The remaining 9 instruction complete one instruction per cycle. How many? One instruction per cycle. Okay, so one instruction per cycle means how many cycle? 9 cycles. 9 cycles. Okay, so simply if we add this 5 plus remaining 9 cycles, so you will be getting 14 clock cycles. So therefore the number of clock cycles required the complete execution of 10 instructions. Okay, again I will repeat, the first instruction takes 5 cycles. How many? 5 cycles. Okay, and the rest, the remaining 9 instruction will complete one instruction per cycle, so it takes 9 cycles. Okay, and your total is 14 clock cycles. Sorry, it will be 14 clock cycles. Therefore the total number of clock cycles required to complete the execution of 10 instruction is 14. That is your option number B is your right answer. Okay, let's move on to the next. Okay, so choose the correct answer from the options given below above. Sorry. Okay. Next. Okay. What it is given? In IPv4 addressing, a block of address can be defined as x dot y dot z dot t slash n, in which x dot y dot z dot t define one of the addresses and slash n define the mask. Okay. So this is true. First statement is true. The first address in the block can be found by setting the rightmost 32 n bits to 0. Yes, this is also true. The address of class C is used for multicast communication. Wrong. Okay, it is not used for multiclass. Addresses are basically in the class D, not in class C. Okay, next. There are 5 classes in IPv4 addresses. Yes, there are 5 classes: A, B, C, D, and E as well. Next, SuperNetting combines several networks into one large network. Yes, this is also a correct statement. Okay, so your option A, B, D, and E are right. A, B, D, and E are right. So your option B is your correct option for this particular answer. Okay, let's move on to the next. Okay, next we have CSMACDA network, right? So consider a CSMACD network that transmits data at the rate of 100 Mbps. Okay, and over a 1 kilometer cable with no repeater, if the minimum frame size required for this network is 1250 bytes, what is the signal speed kilometer per second in the cable? Okay, so first the data given is as bandwidth is given as 100 Mbps. Okay, 100, which we can evaluate to what? 10 raised to 8 beats per second. Okay, remember we need to get it to per second. Then distance is what? 1 kilometer given. Okay, frame length is given L, that is 1250 bytes. Okay, a minimum frame length for CSMA and CD protocol will be TX. Okay, this you should might know, that is TX into 2 of TP. Here TX is what? Transmission delay, that is equal to frame length divided by bandwidth. Okay, so basically your TX is what? Frame length divided by bandwidth, that is L into L divided by B, and your TP is propagation delay. TP is propagation delay, that is your distance divided by speed of signal. Speed of signal. Okay, speed. So let's solve this. Okay, so a minimum frame length is given as this Tx equal to 2 TP, right? So what we can do, we have Tx equal to L by B, and that is twice. So L by B, Tx is L by B, so we can write here L by B, and that is equal to 2 TP. 2 TP. Now we know TP as well. So TP is D by S, that is distance by speed. So LB equal to 2 by 2 of D in D by S. Okay. Now we have all our this equations here, right? So let's cross multiply first of all. So frame length we have 1250, right, into 8, since it is in, okay, bytes, we are converted in bits. Now bandwidth, how much is the bandwidth? Okay, bandwidth is given what? 10 raised to 8. Okay, so 100 into 10 raised to 8. Then we have distance, okay, that is 1 kilometer. Okay, so distance we are taking as 10 raised to 3, and we have 2 here, and at bottom we have S. Okay, so your S will be equal to 2 into 2 into 10 raised to 3 into 100 into 10 raised to 3 divided by 1250, that is your L into 8 bits. So you will be getting something as 20,000, okay, 20,000 signal speed, okay, kilometer per second. Okay, kilometer per second. So this option D will be your right answer for this particular question. Okay, let's move on to the next. Okay, what is SQL primarily used in context of relational databases? To design a user interface, to create and manipulate database, to display data on web pages, to format printed reports. Do print? No, straight away wrong. To display data on web pages? No. To manipulate databases? Yes. To design user interface? No. So straight away, easiest, your right answer is option number B. Let's move on to the next. Okay, given a project that uses COCOMO model with an estimated effort of 200 persons per month, persons month, PM, let's write it, and a productivity rate of 5% month per KLOC. What is the estimated size of the project in KLOC? Okay, so estimated size, first of all, estimated size is equal to estimated effort in PM, persons month, divided by productivity rate. Okay, that is PM per KLOC. Okay, and I guess both we have. Okay, so we have 20,000, 2,000 persons per month, and we have productivity rate as 5. Okay, so straight away you can calculate, this will come 400. Okay, so estimated size of the project is 400 KLOC. 400 KLOC, that is your option number B will be your right answer. Okay, let's move to the next. Dash is a self-balancing tree, okay, where the path from root to the furthest leaf is no more than the twice as long as the path from the root to the nearest leaf. Okay, so for this, the correct answer is red balance tree. Red black tree. Now, what is this? A red black tree is a type of self-balancing binary search tree. It maintains the balance by ensuring that the longest path from the root to a leaf is no more than the twice as long as the shortest path from the root. Okay, so it is basically the definition itself here given. Okay, so your correct answer for this is a red black tree. Now, what is this expression tree? Expression tree is used to represent expressions, not necessarily balanced. Okay, so your option first is wrong. Game tree, representation of possible moves in a game, not self-balancing search tree. Threaded tree, as we know, a binary tree in which null pointers are made to point in order precedor or successor, not specifically self-balancing. Okay, so your correct answer is answer C, red black tree. Let's move to the next. Okay, arrange the following phases of agile process in the correct sequence. Okay, so steps involved. Okay, so first we do what? First we do planning. Okay, that is E, then design, planning, then design, then development, then what? Then testing, and then release. Okay, so we do what? First of all, we do is E, that is planning. After that, we do what? Then we do option A, that is design. Then we do what? Development, that is option D. Then we do what? Testing, that is option C. And then we do what? Release, that is option B. So E, A, D, V, C is your right pattern, and which is option number C is your correct answer for this particular question. Okay, with this we complete our 50 set of questions. Okay, next 50 questions we will be completing in Okay, with this we complete our first 50 set of questions of August 2024 Computer Science Paper 2 question. Next questions starting from 51 to 100 we will be completing in part 2. Do like and share this particular video and do subscribe to the channel Instant Seekh. Thank you. Jai Hind.